Hi, welcome to Math Class with Miss B. I'm excited to be with you today. Today I'm starting my first lesson on a set of 5 lessons that are the fundamentals for algebra. If you want to do well in advanced in algebra, it is very important that you have certain skills and have them mastered. So we will be covering in this one lesson, one of 5, we're going to be covering these Common Core state standards. And by the end of this lesson, you will be able to understand and use the properties of addition, subtraction, multiplication, and division. And you will also be able to understand the order to perform addition, subtraction, multiplication, division, exponents, and parentheses. If you are interested, the following lessons are available on OutSchool. You can follow me on OutSchool to see all the different courses that I launch on there. Okay. So let's go ahead and get started with this lesson. Okay, so first of all, what is an operation? A lot of times I tell people I'm going to teach them about the properties of operations and the order of operations, and they don't have a clue what I'm talking about when I say operation. Operation is just a fancy word. It's one of those high-use vocabulary words that you use in math a lot, and it's just a fancy word for what you do to it. So I tell people, think about when you go to the hospital to have an operation. You are having something done to your body, something done to you. So the operation, in that sense, the operations for math, the definition is the action being performed on the number. Those different ones that you know so far are addition, subtraction, multiplication, and division. So those are the operations, just a fancy word for these 4 things that you already know. An inverse operation, what inverse is basically a fancy word for opposite. So opposite operations. Inverse operations undo each other, or we can say opposite operations undo each other. So let's say I had a jar over here, and if I add 5 marbles to it, to undo that, I would need to subtract those 5 marbles. I need to take them away, right? So addition and subtraction undo each other and vice versa. So they are opposites. They're inverse operations. Same is the case for multiplication and division. If I take something and I multiply by 2, to get back to the regular number, I would need to divide by 2 and vice versa. What is a property? A property is a fancy word for a rule or a law or a theorem. There's many other names that we call these. They are basically facts about how we perform math. It tells us how numbers and operations work. Properties are always true, and you can use them for justification in a math problem. So if somebody says, well, why did you do this way? You can use one of the properties to justify it. Properties, some other names of properties of math would be properties, theorems, laws, postulates, algorithms, a rule. They tell us again how we perform operations. So let's jump right into it. The first property is the commutative property of addition, commutative. And it states that changing the order of add-ins does not change the sum. We got some vocabulary there. Add-in is basically the parts of an addition problem. So I have 1 plus 2, 1 and 2 will be the add-ins, and the sum will be the answer. So 3 will be the sum. The root word here is commute and commutative. Okay, when you think of commute, a commute is basically the distance that you travel from work to home or from home to work. Okay, so if here's home and here's work, and I got to travel 10 miles east to get to work, then at the end of the day when I come home I travel 10 miles west. Well, I'm still traveling 10 miles either way. So the only thing that changed was my direction or the order that I did things. So when you think of commutative property, think commute and think the only thing that changes is the order of the add-in. So changing the direction or the order of my add-ins does not change the sum. So if I had 9 ants and then I add to it 5, I would still have the same amount as if I added the 5 ants first and then added the 9. I still would have in the end 14. Okay, so that's all that says. Changing the order of the add-ins does not change the answer. The associative property of addition, changing the grouping of add-ins does not change the sum. So if I change the grouping of my add-ins, it's not going to change the sum. Grouping or associate is a connection that you have with something or someone. So you have church associates and school associates and work associates and neighborhood associates. These are all people or things that you have a connection with. And we, in math, we show those connections with these grouping symbols, the brackets and the parentheses. So if I have all the same add-ins, 9 plus 5 plus 4 equals 9 plus 5 plus 4, what the associative property states is it doesn't matter if I add the 9 and the 5 together first and then add the 4, or if I want to add the 5 and the 4 first and then add the 9. So if I had 9 plus 5 first, that would give me 14 plus 4 gives me 18. Or if I add the 9 plus, I'm sorry, the 5 plus 4 first, that would give me 9 plus 9 equals 18. So they're still equal to the same thing. Changing the grouping does not change the sum. Then we have the identity property of addition. And it basically says the sum of 0 and any number is that number. So identity is basically being who or what a person or thing is. So if I want 9 to remain 9, the only thing I can add to it is 0. The only thing that I can add to it where its identity will not be affected is 0. Now those were 3 properties that we went over for addition. We're going to go over those same 3 properties now for multiplication, starting with the commutative property. Commutative property, changing the order of factors does not change the product. Now we're talking about factors in product. So the parts of a multiplication problem are called factors and the answer is called the product. Changing the order of them does not change the product. So if I have 4 cookies, each with 6 chocolate chips, it's the same as if I had 6 cookies, each with 4 chocolate chips. I still have the same amount of chocolate chips. Which is 24. Still have 24 chocolate chips. Okay. The associative property of multiplication again, think of connections or that group connection. So if all of the factors are the same, doesn't matter if I multiply these 2 together first versus these 2 together. So if I do 4 times 6 first, I end up with 24 times 2. 24 times 2 gives me 48. As opposed to if I multiply 6 times 2 first, I get 12. 12 times 4 gives me 48. So 48 is equal to 48. So I can do that mentally if I need to because of the associative property says it's okay. The identity property of multiplication. The product of 1 in any number is that number. So what can I multiply 4 by so it maintains its identity? The only thing is 1, and that goes for any number. If I want that number to maintain its identity through multiplication, I can only multiply by 1. The distributive property. Multiplication is distributive over addition and subtraction, meaning it can be shared across addition and subtraction. Distribute means to share what's on the outside of parentheses with each term on the inside. So we're going to take this, because this is multiplication, 3 on the outside of the parentheses means I'm going to multiply 3 times all the terms inside the parentheses. So here it would be 3 times 7 plus, it goes across addition and subtraction, plus 3 times 4. Okay. 21 plus 12, so the answer would be 33. Okay, properties versus equations. So properties of equations. So sometimes we have properties that only pertain to equations. So far we have gone over expressions. An expression would be more like an incomplete sentence. So if I have 8 plus 3, it's more of an incomplete thought if you think of it as in terms of English. However, an equation would be finishing this thought. It would be 8 plus 3 equals 11. Okay, equations have an equal sign in them. Equations are either true or false. And in order for equations to stay true, whatever you do on one side, you have to do it to the other side. And that's what most of our properties are going to talk about. Okay, true equations have equal value on each side, the equal sign of the equal sign, and false equations do not. Okay, so 8 plus 3 equals 11. That would be 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3. So yes, this is true. It's perfectly balanced. When we have an equation, I want you to think of it as a scale, a perfectly balanced scale, where the equal sign is the middle of this scale. Okay? A little funky scale. Okay? Here's my scale. It's perfectly balanced. We got 11 on this side and 11 on that side. Okay? In order for it to remain balanced, whatever you do on one side, you have to do on the other. Okay? If I don't have equal amounts on each side of the equal sign, it's not true. It's false. So this one is true. However, if I had 8 plus 4 on one side, say one side said 8 plus 4 equals 11. That would be this over here and 12 over here. So it would not be equal. You're going to show that with the slash through the equal sign. So this would be a false statement or a false equation, or we could say it's unbalanced. Okay. So with that, the quality properties that we're going to cover for addition, subtraction, multiplication, and division. The addition property of equality basically means we're talking about an equation again, because we see that equal in it, right? Basically states that if I add one number to one side of the equal sign, I need to add it to the other. So here I got 3 minus 1 equals 2. Yes, this is a balanced equation. It's true. So with that said, if I add 4 to one side, I got to add 4 to the other side in order for it to remain balanced, and then I would get 6 and 6. The subtraction property of equality says the same thing for subtraction. So basically, if I want my equation to stay balanced, I have to subtract the same thing from both sides. So here I got 6 over here, 6 over here. It's a true equation. So if I subtract 2 from here, I have to subtract 2 from here in order for them to remain balanced and get 4 and 4. The multiplication property of equality, multiplying both sides of the equation by the same number keeps the equation balanced. So here it's balanced. We need to keep it balanced. So if I multiply this side by 3, I need to multiply this side by 3 also. And I would get 27 over here and 27 over here. Division property of equality, dividing both sides of an equation by the same number will keep it balanced. So if I have 15 minus 3 equals 12. It's perfectly balanced. It's true. I divided both sides by 4. It will remain balanced. Now we get 3 and 3. Okay, so we went over some properties of operations. Now let's talk about the order of operations. Remember, operations is just a fancy word for those add, subtract, multiply, and divide, right? So order of operations, okay? When you have multiple operations in an equation or an expression, you have to follow a certain order in order to perform those operations, okay? So here we have this equation, or this expression, sorry, there's no equal sign. We have this expression right here. And we have 1, 2, 3, 4, 5, 6 different things going on, right? Got an exponent, some parentheses, addition, subtraction, multiplication here, division. It's all kinds of things going on. The problem comes when some people decide they want to do, some people may want to do this first. I want to divide 16 by 4 first. And somebody may say they want to do this first, the exponent first. The problem is if everybody did what they wanted to first, we would have several different answers, probably hundreds of different answers. But the correct way, so everybody gets the same answer every time, is to follow the order of operations, which we use this acronym PEMDAS for. And that means first we're going to do parentheses. Second, we would do exponents. Third, we would do multiplication or division. Fourth, we would do addition or subtraction. And if you get confused with the order, there's also a saying, please excuse my dear Aunt Sally. Remember, this means parentheses. Parentheses includes brackets also, like this. Exponents for excuse. My dear, that would be multiplication or division. Aunt Sally, that would be addition or subtraction. All right, so let's work this out following the order of operations. First, I'm supposed to do parentheses. So I would come here. Inside my parentheses, I see 3 plus 4. I'm sorry, 3 plus 1, which gives me 4. So I'm going to take that and simplify it down to 4. So now I have 8 squared, or 8 to the second power, times 4 minus 16 divided by 4. Next, well, I'm done with my exponent, my parentheses. Next, I look for exponents, which would be here. This 8 squared, or 8 to the second power, that would give me 64 times 4 minus 16 divided by 4. Notice I keep rewriting my equation. It helps me keep everything in order and make sure I simplify it. Okay, so now I get 64 times 4 because I have multiplication, subtraction, and division. In this case, I have multiplication first. So that's why we say or, multiplication or division here. Multiplication or division, meaning whichever one I see first in the problem. So since I saw multiplication first, I'm going to do this part first before the division. So that would give me 64 times 4 gives us 256 minus 16 divided by 4. So now I have subtraction and division. Well, which one comes first? Please excuse my dear, that will be the division. So I'm going to do this part next. It will be 256 minus 4. Now I'm down to one operation. 256 minus 4 gives me 252. So that concludes this lesson in the series of 5. If you like what you see, please give me a thumbs up. You can subscribe to my channel. I will be loading more videos like this. And also you can follow me on OutSchool if you would like to enroll one of your learners in one of my courses. Bye.